So we're not going to talk about simple interest right now. I thought about it and I decided, I just in my head decided a couple minutes ago that we'll wait on simple interest. We're going to talk about something very specifically called compound interest. I think you'll find it to be mildly interesting. And again, pun, and for once, pun not intentional. Like I said interesting, but I didn't mean to try to be funny. Got it? So I'm going to talk you through and show you through an example of how compound interest works. And then we're going to talk about a really scary looking formula for how to do compound interest. And then we're going to practice that formula for at least a couple of days, probably. Well, at least one full day. So, and it does not, Delta Math doesn't have any of this. So we're going to use IXL when the time comes, just so you know. All right. So let's get to it. Here's an example. Let's say you have $100. And first off, let me just coach you through. I said I wasn't going to talk about this, but I guess what I meant to say is we're not going to do a full lesson on this. If I asked you to calculate simple interest on that of 10%, here's how this would work. If you got 10% simple interest is, it doesn't build off of other interest accrued. So here's what I mean. Peyton goes to the bank and she puts $100 in and she gets 10% simple interest. A lot of this I want you to be able to do in your head. Do you guys all know what 10% of $100 is? It's just literally $10. So that's easy. Percent literally means out of 100. It's directly translated to that. So Shariah gets $10 in interest, and her bank account now says $110, right? And then the next year she gets 10% simple interest again. But the thing is about this is she only gets 10% of her original account balance, what she deposited. So this time when Shariah gets her 10% bonus, she's still getting 10%, but unfortunately she's getting 10% of that. And what's 10% of 100? It's $10. What's going to happen with simple interest is it's called simple for a reason. Like it just never changes. Like you get $10, you get 10 more, you get 10 more, you get 10 more. So simple interest is pretty unexciting. It's that'll lead us into then talking about compound interest. And compound interest is way more exciting and way more real worldy and way more cool. It's harder to calculate, but it's really cool. So in this example, let's talk about compound interest so you can see how this actually works. It's really neat, I think. But again, I'm biased. So Shariah goes down to the bank. She deposits her $100, or Peyton or whoever, it doesn't matter. And she gets 10% compounding interest. So the first time she gets interest, she gets 10% of her 100, which we all agree is $10. And that gets added into her bank account balance. And what is her new balance? She now has $110. But this is where the word compound comes into play, is that the next time her interest gets calculated, what is she getting 10% of? Yeah, that's the beautiful thing, is that the money that goes into your account is now considered when you build interest off of that. So Shariah is now getting 10% of $110. And what is 10% of $110? We're going to be doing, don't worry, we're going to use our calculators a lot, but for now, just know that 10% is just moving the decimal place. So that's $11. So I'm going to add $11 now to Shariah's bank account. Like, well, who cares? That's different. It's better than last year. Last year she got 10, this year she gets 11. So what's her new bank account balance? Good. And now in the next time she gets 10% interest, what is she getting 10% of? She's getting 10% of the new balance, which is $12.10. So now I'm going to add $12.10 to Shariah's bank account. And what does she have? $133.10, right? Is that correct? Is my math okay? 133.10? Good. And this is going to get out of hand to the point where we don't want to keep doing this by hand. But I hope you're seeing and picking up what I'm putting down here is that the essence of compounding is that the interest compounds upon what got put in there before. You add a little bit to the base, you get more interest. That goes back into the base, you get more interest. And it keeps on happening and it keeps on happening. So let's do maybe one more time of this process and then we'll talk about the formulaic way to do it. So If I take 10% of Shariah's new balance, what is 10% of 133.1? 1331, I think. Did I do any math? Yeah, 1331, right? Got to just move the decimal one place to the left. So over here. So 10% of that is $13 and 31 cents. And if you add those together, what is Shariah's new bank account balance? 146.41. Correct. Do you see what's happening here? It's not particularly exciting. And to the untrained observer, you'd say, well, that's not even worth the effort. Because if we were doing simple interest, it would have gone 100, 110, 120, 130, 140. And you'd not be wrong if you said, well, those aren't enough for me to even justify paying attention right now. Trust me that it becomes enough. What happens with these things is they grow, and they grow like this. And what you find, that's called an exponential curve, is that nothing exciting happens in like the first 20, 10, 15, 20 years, right? Nothing exciting. You just keep looking at it. And then there's one magic point in every exponential math problem right around here where things just go jackpot. That's well played, sir. Well played. So can you imagine if I asked you to do this problem, but I asked you to do it for the next 30 years? You'd be really mad at me, and I'd probably just have to run out of the room, right? Because it already got annoying, and we were only on like the fourth iteration of the process. So there's a formula for it. And I hope you're still paying attention because I'm going to show you the formula. And you should write it down. You ready?
Should we? Unless I wrote the last formula.
Let's just write it one time. All right, this is it, one time. I'm going to write in my very best handwriting so you can read.
Put it in red.
All of my, yes, I'll write it in red.
Fraction.
Yeah. This formula looks really difficult, but you'll be like by the middle of class tomorrow, because I only got like 13 minutes today, but middle of class tomorrow, you're going to be just rocking this thing. Once you know like who everybody is, easy peasy. So let's talk about the cast of characters first of all, because in this formula, I see a buttload of variables. I see A, R, N, and T, M, P. So let's talk about who they all are. So A is kind of like the final amount. And that can be after 5 years, 20 years, 30 years. It really just depends. Like, as you know about formulas, they have letters in them because we don't know what's that? Right. And so A is just going to be where the final answer will go eventually. And then does anyone want to take a guess as to what P is? Say it again. Yeah, it's called your like initial value. You can call it that initial amount, I think. So every problem that I give you is going to have a starting point. Like I'll write a math problem like Aiden goes to the bank and makes a deposit of $3,200. Bam, there's your right, $32, $320, whatever. The point is that is your P. As soon as someone says this is where the problem starts, that's your P. Let's keep going. Anyone want to take a shot at what R is? Nope. It's the interest rate, hence the letter R. And I've still got a couple of colors to go, so I got 2 variables to go. T, guys, what does T normally stand for in a problem? time. So in this case, it's going to be, usually we say just the number of years. And you're right, it is totally, it stands for time. But in the problems that we're going to work, it's going to be like, how many years have passed? If the question is like, okay, Trinity made an investment of $5,000. She got an interest rate compounded annually of 5.6%. How much money will she have after 13 years? Then, you know, boom, I'm putting 13 in place of T. Good. And for now, for our notes, just to make your life a little bit easier, do you see how you have the same variable here and here? You see that? That's the number of times compounding happens every year. I will say that for now, do not come back and say you said this. I'm saying this. For now, for a day or so, your end value will be 1. Got it? As soon as I change it, though, as soon as I change it to quarterly compounding or monthly compounding or semi-annually compounding, then N is going to change. But for the next little while, just rest assured that the N value is just going to be. Okay, you ready to press on? Got the formula? Got your cast of characters described?
Do I have a formula?
No! Let's go back and do our problem again. So here we go. I'm going to show you how this works. So we're going to deposit. Adios, hasta mañana. We're going to deposit $100. We are going to get 10% interest compounded. What does annually mean? Every year, right? And we want to, let's leave our money in there for 40 years. Would anyone like to guess as to how much $100 might be worth after 40 years of 10% compounding? You think it'll be a lot, like a few thousand maybe? That's a lot. Let's find out. The what amount? We're going to solve it. I see you all looking at your calculators. I can never tell who's listening, so it's really hard for me to do this because I can't tell. But just to be clear, it wasn't just you. To be clear, we're going to do a math problem. We're going to invest $100. We're going to get 10% interest every year, and we're going to leave our money sitting there untouched for 40 years. So the question's going to be, how much will we have after 40 years? So I'm going to show you now how to set this up, okay? Listen, your other option is to say, well, I'm just going to do it the way he showed me, except I'm going to repeat that process 40 times. Like I said, you'll go nuts after like 10, 40. Oh my God, couldn't pay me enough. So here we go. Here's the setup. We're going to copy down our formula. And in place of A, we're going to put A. Now's a good time to start writing. Now, you have the formula there. It's right in front of you. And so the next variable that you see is P. Do we know P? It is. That's your initial investment amount. So since we're starting our account with $100, we're going to put 100 where the letter P used to be. Yeah, sure. Yeah. And then we're going to open a set of parentheses, and we're going to put 1 plus. I'm just copying the formula, just so we're clear, okay? What's the next variable that we encounter up on top? The R, and that's 10%. However, if you put 10 here, you have to move the decimal twice to the left and put 0.1. And that's usually where I find most mistakes happen, unfortunately, is that the decimal doesn't get moved correctly. So remember, 10%, the decimal is currently here. I'll make it red for you. And when we convert it to a decimal, we go 1, 2, and that's where that number comes from. Now remember what I said, right? Is that N is going to be 1 for a little while. And so since the interest is compounding annually, that means it happens 1 time per year. So we're going to put
I don't know why you should be saying that. That is not what I mean.
And then in the top, there's an exponent, and the exponent consists of two numbers. They are n and t. In this problem, what's n? And what's t? What's 1 times 40? Good. Now I'm going to teach you how to type this into your calculator. Please don't say the answer until we've all had a chance to type it in. So here's what it's going to look like. You better get good at this because it's like all you're going to be doing for a couple days. So I'm going to start by typing the number 100, and I do not need to put a time sign. I'm just going to start a set of parentheses. And then I'm going to put 1 plus, and listen, can we all agree that 0.1 divided by 1 is just 0.1? So if you don't want to put the divided by 1, you don't have to. Eventually, that number is not going to be a 1, and it's going to matter. But for today, let's just put it in as 0.1, like this. Close your parentheses. I assume by this point, you know how to find an exponent on your own calculator. So we have to do 2 the power of 40. It probably doesn't look like that on your screen. Your screen probably looks like an actual exponent. I don't know. Let me get caught up to you here. Does yours look like that? The TI-30 does? I got 4525.925557. Did you type in exactly what I have?
You'll knew your parentheses.
Oh, I think I'll warn before the. Here, you try.
So what that means, and you guys actually weren't that far off. You said $4,000-ish, and I was like, oh, there. Let's do the exact same problem again. Good. Let's do the exact same problem again, but let's jump it to 50 years. Got it? So we're upping it to 50 years now. So what we're going to do is we're going to go to the bank. We're going to put $100 in an account. It's going to get 10% compounded annually interest. We're going to let it sit there. We're going to come back in 50 years, and we're going to see how much money is in the account at that point. I'm looking at 11,739 bucks.
Yep.
And what's interesting, let's think about this. Think about this, math people. In the first 40 years from the time I walked down to the bank and put my $100 in, how much did it grow? In the first 40 years. So I went to the bank, and on day zero, I had $100 in my account. How much did I have after 40 years? 4,526 bucks or so. After 50 years, how much did I have? 11,700. A non-math person is either sleeping right now or acting like they're listening and completely bored. A math person, you're going to find this to be somewhat intriguing. This account grew in the first 40 freaking years. It only grew by $4,000. And then in a 10-year span, a tiny little 10-year window, it grew 11,000 more. It grew 7,000 more. Let's go to 60 years. Calculate it for 60 years. Practice. So do your 100 times 1 plus 0.1 to the power of 60. Now how much do we have in our account? 30. So now let me get this straight. So in the first freaking 40 years, you did bupkis. You grew 4,000 flipping dollars, right? But then in the next 10 years, you grew 7,000 more. And then it just grew 20,000-ish in the last 10 years. That's that curve I was showing you about how things grow quicker as we go. Got it? Make sure that tomorrow, because I got to let you go now, tomorrow be ready to do some more compound interest. So, yeah, we're going to work together for a while, and then there'll be some IXL time. Tomorrow? Yeah. I don't know. If there's teaching, there'll be a video. Yeah, I'll video it for you.